Grapes hit the winery gate as a time-critical raw material, because the moment a berry is picked, enzymes start working, wild microbes wake up, and temperature decides whether you preserve fresh aromatics or drift toward oxidation and volatile acidity. In a large, modern Napa operation associated with a name like Robert Mondavi, the factory part isn't about anonymous volume. It's about running harvest like a precision manufacturing campaign where every lot is tracked, tested, sorted, and moved through stainless steel infrastructure. It's fast enough to protect flavor. The first high-tech step is intake and identity control. Each bin or gondola is logged by vineyard block, varietal, pick time, and target wine program. Because Cabernet from one hillside lot is not processed the same way as Sauvignon Blanc from a cooler site. Before the fruit even touches a crusher, lab techs measure Brix for sugar, pH and titratable acidity for balance, and berry temperature to decide whether the lot needs immediate cooling. That data determines the entire downstream recipe: yeast selection, fermentation, temperature, maceration time, and how much oxygen exposure the winery can tolerate. Cleaning and sorting is where modern wineries separate prem wine from harvest chaos. A conveyor. Systems feed clusters through destemmers while blowers remove leaves and stems. Because vegetal material adds harsh phenolics and green aromatics, high-end lines add optical sorting that uses cameras and air jets to reject underripe berries, raisins, and moldy fruit at speed, because one compromised cluster can introduce off flavors and microbial load. Even the way grapes move matters. Gentle low-drop conveyors and progressive cavity pumps reduce berry tearing, which reduces early oxidation and prevents extracting bitter seed tannins. From here, the process splits immediately into two different manufacturing routes: white wine logic and red wine logic. White winemaking is about extracting clean juice while minimizing skin contact and oxygen. Red winemaking is about controlled extraction from skins, because color and tannin live in the solids. For whites like Sauvignon Blanc, the winery often aims to keep aromatics intact by limiting oxygen and keeping the must cold. Grapes may be pressed as whole clusters or lightly crushed, then sent to pneumatic membrane presses. Pneumatic presses inflate a bladder inside a perforated drum, squeezing gently in programmed pressure cycles. That programming is critical. Low pressure extracts high-quality free-run juice. Higher pressure extracts more yield but brings phenolics and bitterness. Juice fractions are often kept separate, so the winemaker can blend only what fits the target style. Freshly pressed juice is cloudy and unstable, so clarification happens fast. Some wineries use flotation, injecting fine gas bubbles that lift solids to the surface for removal, creating clear juice without long settling times. Others cold settle in jacketed tanks, letting solids drop out while temperature control holds the juice in a safe low activity zone. Clarification is not cosmetic. It controls fermentation kinetics and aroma development, because too many solids can drive reduction and off odors, while to clean a juice can ferment sluggishly and strip texture. Fermentation for whites is executed like a temperature-controlled biochemical reactor. Stainless tanks use glycol jackets to remove heat generated by yeast metabolism, keeping fermentations in a narrow temperature window that preserves volatile thiols and esters. Yeast is not a generic ingredient. Specific strains are selected for aroma profile, nutrient demand, and alcohol tolerance. Nutrient additions are measured, not guessed, because nitrogen deficiency causes stuck fermentations and sulfur aromas. Dissolved oxygen is monitored because small oxygen dosing early can keep yeast healthy. But oxygen later destroys freshness. Some lots may be fermented in barrel for texture. Barrels aren't just flavor containers. They change oxygen transfer rate. Oak provides micro-oxygenation through the wood, which can soften perception and build mouthfeel if managed correctly. Lees stirring, called badinage, is a mechanical action used to resuspend yeast lees and release manna proteins that increase body instability. That's why wineries track lees contact time and stirring frequency like a process parameter, because too much lees reduction creates off notes, and too little leaves a thin palate. Now switch to reds, like Cabernet Sauvignon, Where the factory goal is controlled extraction, grapes are destemmed, often lightly crushed, and pumped into fermentation tanks designed to handle solids. The must includes juice, skins, and seeds, and as fermentation begins, CO pushes skins upward to form a cap. If that cap dries out, you get uneven extraction and microbial risk. So the winery uses cap management systems. Pump overs are the workhorse. Wine is drawn from the bottom and sprayed over the cap to wet it evenly and extract color and tannin. Punch downs physically push the cap down, increasing contact and extraction. Some facilities use automated pump-over manifolds and programmable cycles to control intensity by time, flow, and frequency. More aggressive cap management can build structure for long-aging wines, but it can also pull harsh tannins. So the process is tuned to the lot's ripeness and the wine's target style. Temperature. Control in red fermentations is just as critical as in whites, but for a different reason. Warmer fermentations extract more color and tannin and can accelerate fermentation. But too hot and you volatilize aroma and risk stressed yeast. Large fermenters use glycol jackets and sometimes internal cooling panels to remove heat from the core, because a big tank can develop thermal gradients where the center runs hotter than the shell. Sensors monitor temperature at multiple heights to prevent HOTS/POTS. As sugar drops, the winery tracks fermentation rate with density measurements often automated. A stable, predictable drop in Brix means yeast is healthy. A stalled curve triggers intervention, nutrient adjustment, controlled oxygen, or temperature shifts. Red fermentations may run extended maceration, keeping wine on skins after dryness to polymerize tannins and build a smoother texture. But that decision is chemistry-driven. Time increases extraction and changes tannin structure, so it's only used when the fruit quality supports it. Once reds finish, the next mechanical separation is pressing, and this is where the winery decides what becomes premium and what becomes blending material. Free-run wine drains off first and is typically softer and cleaner. Press wine is extracted by pressing the pumice, and because pressing extracts more tannin and phenolics, it's tracked as a separate stream. A high-tech winery keeps these streams separate with full traceability because blending is how the final wine is engineered. After alcoholic fermentation, many wines undergo malolactic fermentation, a second controlled microbial process where bacteria convert malic acid to lactic acid, softening the wine and improving microbial stability. This is managed with temperature, sulfur dioxide timing, and lab verification, because incomplete malolactic can cause instability in bottle. In premium programs, barrels and tanks are tested repeatedly until malic acid is effectively zero. Aging is where the winery looks less like food processing and more like inventory engineering. Barrels are managed as a controlled oxygen and flavor input. French oak versus American oak changes lactones, spice notes, and tannin contribution, and toast level changes the mix of vanillin, smoke, and caramelized compounds. Each barrel is tracked by cooperage, toast, fill date, and lot, because consistency across thousands of barrels depends on data, not memory. During aging, the winery manages oxygen exposure with topping, the simple but critical practice of filling barrels to replace evaporated wine and prevent excessive headspace oxygen. Racking transfers wine off sediment, reducing reductive off odors and refining texture. Some operations use micro-oxygenation in tank, injecting tiny measured oxygen doses to mimic barrel oxygen transfer, accelerating tannin integration without adding oak flavor. Asterisk stability and clarity are engineered before bottling. Fining agents selectively remove unwanted compounds, proteins that haze white wines, excessive tannins that create bitterness, or phenolics that cause instability. Filtration is chosen based on wine style and risk tolerance. Crossflow filtration can clarify without filter aid powders and can run continuously with less waste. Final sterile membrane filtration is used when microbiological stability must be guaranteed, because a single surviving yeast cell can restart fermentation and bottle. Bottling is a precision packaging operation where oxygen control determines shelf life. Bottles are rinsed or ionized, they're cleaned, then filled on rotary fillers designed to minimize turbulence. Many lines inert the headspace with nitrogen or CO2, reduce total package oxygen, because oxygen drives premature aging, browning, and aroma loss. Corking or screw capping is torque and compression controlled, because a poor seal means variable oxygen ingress and inconsistent aging. Inline sensors check fill height, closure presence, and label accuracy, and defective units are rejected automatically.
This Cabernet should pair nicely with the smoked Gouda.
Yes, and let's try the Prosecco too.
Happy Thanksgiving, everyone. Cheers! Happy Thanksgiving! Very good, sir. Allow me to pour the remainder.
Thank you. Cheers, everyone, to a beautiful night. Absolutely perfect. Don't mind if I do, this party is amazing. I know, right? Did you try the appetizers yet? Look at that smoke ring. It's ready.
Cheers, everyone. This pairing is incredible. Food just melts with the Cabernet.
It really is. The texture is perfect.
Quality control is continuous, not ceremonial. Dissolved oxygen and total package oxygen are measured because they predict how the wine will taste months later. Microbiology testing checks for spoilage organisms like Brettanomyces, which can produce barnyard aromas if allowed to grow. Sensory panels validate that chemistry matches perception. Because a perfect lab sheet can still hide imbalances that show up on the palate the million tons. Idea is the feeling you get from harvest intensity, not literal scale for a single winery, because premium regions are constrained by vineyard acreage and quality targets. What is real is the industrial discipline. Rapid intake, automated sorting, temperature-managed fermentation, data-logged aging, and oxygen-controlled bottling. That discipline is what turns grapes variable, perishable, and site-specific to a consistent portfolio of wines. Built, lot by lot, with the same mindset as any high-value manufacturing process. Measure the inputs. Control the reactions, separate streams intelligently, and protect the product from contamination and oxidation all the way to the final seal.